The main goal of SACI is to help sensor data researchers to easily collect, process, store, and access large volumes of heterogeneous sensor or device data on the cloud. And our system supports easy registration, real-time data ingestion, processing pipelines, and data querying. So SACI can make individual researchers to easily collect and analyze real-time sensor data and to enable stakeholders to explore the data and make timely decisions on policies and practices. The front end is deployed on MyGeoHub, the Geospatial Science Gateway, and the backend is deployed on Jetstream Cloud Virtual Machine. So here is an overall design and software stacks to build a system. Briefly, SACI provides REST API access point to users or devices by Node.js. And each data flow from various sources are controlled by RabbitMQ message queue system, and the Docker container takes the data processing. The backend database is based on the MongoDB. We'll see how each component works with the data flow in the next slide. There are three main workflows in SACI system. The first one is the source registration. As you see here, a researcher or data producer can register a database using our SACI portal. Once the user submits the request filled with the metadata and the request is accepted, the SACI automatically creates the pipeline for the new data source at the backend, including the API endpoint, dedicated message queue, data processing container, and the database table. And all these things can be ready within a minute. Next is the data ingestion. Using the API endpoint, each device or sensor can send the data into our system. Once the data arrived in our system, the data is passed to the dedicated queue and waiting to be processed by a processor for that data source. After the containerized data processor receives the data and performs necessary pre-processing steps, the data is going to be stored in its data table. Last is the data analysis. Data consumers or clients can easily query and access the sensor data through its REST API, like the data ingestion. Also, it is possible to perform data fusion and transformation and then feed the data into models that can be run either locally or on remote HPC systems. So we will show you a demo using SACI with an ongoing project called LeafSpec and a new project called Water Physical Chemical Sensor. In LeafSpec project, a research group at Purdue University has developed a handheld plant phenotyping sensor device, which is capable of sensing accurate plant health data. The LeafSpec could be used by researchers to predict plant growth and by farmers to direct fertilizer and pesticide application in the field, or by decision makers to monitor drought and other stress situations across a large region. In the new water physical chemical project, each sensor will send various water physical chemical parameters like pH values, temperature, conductance, etc. in various frequency. Now, we switch to the live demo in SACI and its workflows for data registration, data ingestion, and analysis. This is the SACI portal deployed on MyGeoHub. On the left side, we are seeing the SACI portal of the specific user, and on the right side, it shows the admin page to see the entire databases in SACI system. Basically, in the first dashboard tab, it shows an overview of the databases created by the user. For example, the data source name and its API access point, the number of records, last ingestion time, and its status, etc. In the registration tab, a user can register for his own database by specifying the metadata. And in the management tab, A user can modify the metadata of the existing data source, for example, adding or removing attributes in the database. For the new registration, here I've already put the metadata of our new water physical chemical project, where the sensor sends data with 18 attributes. Once I submit this information, the request is pending on SACI admin's approval. So let's approve it on admin page. Now, every necessary steps for creating users database are ongoing in the backend. In detail, it creates the API for the ingestion and the querying for this specific data source, and configure the message queue as well. Also, it attaches the pre-processing pipeline into the dedicated message queue and make the backend database table ready. Once the registration is done, it is ready to be used, like this one. So for now, let's ingest some data using the two sample data sets from the water physical chemical project and the LeafSpec project. On the left side, we're gonna read sample data from water physical chemical project and send the HTTP request to the dedicated API address. So if we execute this script, the data is ingested line by line. And as we check the users portal here, we see that the number of records is increasing, meaning the data is being ingested. For the other example of SACI ingestion, on the right side, we see the web application for the LeafSpec project, showing the most recent data points ingested into the system, highlighted with red circles and refreshing every second. By running a sample ingestion script like before, we see that the data is getting ingested on the application. Fetching a data from SACI also can be done with a simple HTTP request to the access point. From the water physical chemical project, let's say we want to get the temperature values within specific range from the previous ingestion. So this is the example query. Here, we set the date is on December 7th, 2015, and the time is greater than 10 o'clock and less than 11 o'clock. And then select the temperature attribute. If we send this request, the data is fetched from the server and returned it as a JSON string. On the other LeafSpec example, we've implemented a data visualization feature to analyze the data for a specific range. So if we set specific parameters like this and send a request to the SACI access point, it fetches data from there and shows the visualization results. In this example, this interpolation result for plant health in this region would be helpful and give some intuition to researchers, farmers, or stakeholders. So we are back to the slides. As the future works, we will measure our performance of SACI system in detail and make it as a scalable platform to handle multiple users at a time without losing performance. Also, we are thinking to provide add-on pre-processing step for users as they may want to customize it. For example, users may want to filter out some data that is not in specific range, or they want to tag some index value in the data on the fly. Lastly, we will add visualization feature in SACI portal to show the detailed overview of the data source. In conclusion, we've covered SACI system design and how it can be used in sensor data collection, processing, and management. Also, we've seen the detailed workflows with running examples and how SACI provides an easy-to-use and cloud-based database system. With SACI platform, we expect to have a collaboration with researchers, scientists, and educators from various fields. Thank you for your attention, and let me know if you have any questions. Thank you.
Thank you so much. Does anyone have any questions for Jae-woo? There's a question in the chat. Is there a link to the presentation or a link to your site? I know that the presentation itself should be stored with the files for Science Gateways, but Jae-woo, is there a link that you have or a site that you would like to share?
So do you mean the link for the video or link for the platform?
Both, I believe. The video presentation as well as your platform.
Yeah, I can share you in the chat. Yeah, I will copy and paste the link for that.
Thank you.
Yeah, by the way, for the platform, it is for now not open to the public. It is under the development page. So yeah, I will first share the link for the video, but in the future, if it is on the public, I can, if you, mail me the link for that, I can share you.
Sounds good. Jae-woo, just take a moment to put your name and email in the roll call area of our Kiko chat, and then people will be able to contact you by email. Thank you.
Okay, yeah, all right, thank you.